Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question as old as starlight itself. Could we, in all our curiosity and ever-growing understanding, truly predict how the universe will end? It sounds like the kind of idea whispered by philosophers beside ancient fires. Yet here we are in the modern age, with instruments orbiting Earth and telescopes that peer across billions of years. And still, the ending remains one of the most delicate mysteries we have ever tried to touch. Before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you genuinely enjoy these quiet wanderings among the stars. And if you feel comfortable, leave a comment to tell me where in the world you're listening from and what time it is for you right now. It is always such a gentle wonder to see the places we gather from, each of us living in our own little corner of time. Now feel free to dim the lights, maybe let a fan hum softly in the background, and settle into whatever position feels most comfortable. As you breathe slowly, imagine the night spreading out around you like a warm, endless ocean. Picture the faint shimmer of distant galaxies drifting just beyond your reach, as if they're inviting you to float closer for a moment. And if your thoughts begin to wander during our journey tonight, that's perfectly all right. Just let them drift, knowing that the story will continue unfolding softly around you. Let's begin our gentle voyage into the question of how the universe might one day take its final breath, and whether that final moment is something we could ever foresee. When you close your eyes and picture the universe, perhaps you imagine a vast darkness sprinkled with stars, or a sweeping spiral of galaxies curling like a luminous flower. It feels eternal, almost untouchable. Yet, astronomers and physicists agree on something quietly astonishing. The universe had a beginning. It wasn't a slow dawn or a gradual awakening. It was more like a single, brilliant spark, one that expanded and cooled and gave birth to everything you've ever known, from the warmth of sunlight on your skin to the unseen particles drifting through the room around you. In this calm moment, imagine that beginning as a single breath, not a human breath, with lungs and air, but a breath of existence itself. The universe exhaled into being, and in that soft expansion, time opened, space stretched, and the first ingredients of matter appeared. What we now call the early universe was hot and bright beyond imagination, yet fleeting in its first steps. As it expanded, it cooled just enough to allow the very first structures to emerge, tiny seeds that would one day become galaxies, stars, planets, and perhaps even stories like this one. For billions of years that gentle unfolding has continued. The universe grew larger, the stars lit up, and space became filled with places where life might one day notice the beauty around it. This is where we find ourselves, in a quiet pocket of a cosmic story, already 13.5 billion years long. And because we know it had a beginning, it is natural, almost inevitable, to wonder whether it might also have an ending. But before exploring how everything might one day fade or fall silent, it helps to understand the rhythm of the universe as it currently breathes. Imagine the cosmos not as a static emptiness, but as something always stretching, always shifting. Even right now, every distant galaxy is drifting away from us. Not because it's moving through space, but because the space between us is gently widening. It is a motion so vast and so slow to our eyes that we only recognize it with careful measurements, like watching a coastline move by a fraction of a millimeter over centuries. This stretching of space is driven by a quiet pressure that fills the universe. You can picture it like a subtle wind that moves through all of existence, a wind so faint we cannot feel it, yet strong enough to push galaxies apart over billions of years. Some scientists call this pressure a cosmic push, while others describe it as an energy woven into space itself. The true nature of this force remains a mystery, wrapped in a softness that refuses to reveal its full shape. But we do know one thing. This gentle push influences how the universe might eventually end. Alongside this quiet wind is another force pulling in the opposite direction: gravity. Gravity is the great gatherer, drawing matter inward, shaping stars, building galaxies, holding planets in their orbits. If the cosmic push is a soft wind spreading everything apart, gravity is the steady hand that tries to keep things close. The end of the universe depends on which of these two forces holds the greater patience across unimaginable spans of time. And so, the question arises, is the universe destined to continue expanding forever, drifting toward a future where stars fade and galaxies vanish beyond each other's sight? Or will gravity, at some distant moment, begin to slow the cosmic stretch, drawing everything back inward until the universe folds into itself once more? Or could the cosmic push grow too strong, unraveling galaxies, stars, planets, even the atoms themselves? Each possibility paints a different picture of the final chapters of existence. For now, we live in a spectacularly balanced moment. The universe is expanding quickly enough that distant galaxies move away from us, yet slowly enough that stars still form, planets still orbit, and life still has room to wonder. It is a delicate harmony, like a candle flame that holds its shape even as it flickers in a breeze. As we begin this journey through the possible endings, it's worth remembering that we exist in a rare and privileged time, a cosmic morning where light still fills the sky, and the universe is young enough to be lively, yet old enough for minds like ours to ask these quiet, profound questions. Before we drift onward, take one more slow breath, letting the vastness of this moment wrap softly around you. The universe began with a breath, and now, together, we are tracing the gentle arc that leads us toward whatever final breath may come. When you think of time, you might imagine the steady tick of a clock, the gentle glow of a phone screen turning from 1 minute to the next, or the slow brightening of dawn through a window. These are small, familiar rhythms, held close to a human heartbeat. But the universe keeps time in a way that feels almost otherworldly. It does not mark seconds or minutes. Instead, it turns its pages across billions upon billions of years, moving through grand eras that unfold like sweeping chapters in a book, too vast for any single being to read from beginning to end. Tonight, as we drift a little deeper into this quiet exploration, imagine the universe not as an endless expanse, but as something with phases, distinct moods and tones, like the movements of a gentle symphony. Each era carries its own character. Some are bright with creation, others are slow and contemplative, and the furthest ones lie so deep in the future that they feel almost dreamlike, as though they belong to a universe that no longer resembles the one we know. The first major era we live in today is sometimes called the Age of Stars, a poetic title that fits surprisingly well. This is the bustling, luminous chapter, where stars ignite across the cosmos, galaxies swirl like lanterns in a vast night, and planets gather around young suns. It is an era still filled with warmth and light, where the raw ingredients of life can form, settle, and grow. If we reduce the entire lifetime of the universe to a single day, this age, rich with starlight, would be the glowing hours of early afternoon, full of energy and movement. To picture this era gently, imagine yourself standing in a meadow just before sunset. Fireflies hover near the tall grass, lighting up one by one, and even from a distance, their glow brings a soft magic to the scene. That is the universe right now, full of tiny flickers of brilliance, each star a firefly against the darkness, each galaxy a shimmering constellation of possibilities. But just like the meadow grows quieter as night deepens, the star-filled universe will not stay this way forever. When the supply of fresh gas, the material stars use to form, begins to run out, the bright afternoon of the universe will slowly give way to evening. Fewer new stars will be born. The ones that remain will burn steadily, but eventually they too will dim, fade and settle into long sleeps as dark, cooling remnants. This distant phase is sometimes described as the time of stellar embers. Imagine walking through a house long after a gathering has ended. The candles have burned low, leaving only faint glows along the edges of the room. It is quiet, almost serene. The universe will eventually reach such a moment where the once dazzling star fields give way to a softer, darker kind of beauty. Yet even after the last visible stars fade, the universe continues to change. Far beyond anything we can measure today, a time will come when only the faintest whispers of heat remain in the matter scattered across space. Black dwarfs, cold remnants of stars, will drift silently, their glow long gone but their presence still marking where brilliance once lived. Planets will cool until they barely hold any residual warmth at all. The darkness will deepen, not harshly but gently, like the slow dimming of a lantern on a quiet night. And then, still deeper in the future, a new chapter begins. The universe enters what some thinkers call the age of black holes. These are the great anchors of galaxies, vast, heavy structures that once held entire regions of space together. As time stretches on, black holes will slowly gather the loose material around them. Wandering stars, forgotten fragments, even the last drifting remnants of galactic cores. Their gravity remains strong, even as the universe continues to expand around them. For a while, black holes will dominate the cosmos, each one a silent giant in the dark. But even they are not eternal. Over astonishing spans of time, far beyond anything we can easily imagine, these giants begin to release their energy back into space through faint, steady radiation. It is a whisper of light escaping the boundary of darkness, so gentle that it would take longer than the entire visible age of the universe to notice any change. Eventually, even the greatest black holes fade away, leaving behind a universe that is vast, cold, and nearly empty. This final era is sometimes called the Quiet Eternity, where the last traces of heat slowly even out until the cosmos reaches a calm stillness. It is not a dramatic ending, not a sudden collapse or violent burst, but a long descent into silence, a whispering fade into cosmic night. As you hold this story in your mind, notice how gracefully the universe moves through its eras. There is no rush, no abrupt turn. Each chapter flows into the next with the patience of something that has no need to hurry. And while these eras stretch across unimaginable length of time, they help us understand the larger arc of the universe's life. They show us that the cosmos, like a great tree or a tide washing over sand, changes in slow, measured rhythms. What makes this framework so important is that it gives us a way to think about the future. If the universe has moved through these grand movements in the past, then perhaps the unfolding of the next chapters, whatever they may hold, also follows certain patterns. This is the first step toward predicting how everything might end, not through sudden revelations, but through careful listening to the quiet music of cosmic time. As we drift further on our journey tonight, we'll begin to explore the forces and mysteries that push the universe toward one ending or another. But for now, let the thought linger softly. We are living in a single luminous paragraph of a story so immense that most of its pages remain untold. Take a breath and let the universe's quiet clockwork continue its slow turning in the background. If you've ever watched a leaf float along a quiet river, you'll notice something lovely. The leaf doesn't decide where it goes. It drifts because the water beneath it pulls in one direction, while a breeze above it nudges in another. One force gathers, another spreads, and the leaf simply follows the outcome of their gentle contest. In many ways, the universe moves in a similar fashion. It follows the subtle tension between two grand forces that shape everything we see: the force that pulls inward and the force that pushes outward. The inward pull is the one we know best. It's the familiar companion that keeps your feet on the ground, guides the moon around Earth, and brings stars together into glowing clusters. This pull is gravity, but for tonight, think of it as the great gatherer. Wherever matter exists, the gatherer is at work, drawing things gently together, never shouting, never rushing, simply pulling with patient consistency. When you look up at a night sky full of stars, you're seeing the gatherer's handiwork on an unimaginable scale. The opposite force, the outward push, is far more mysterious. It's not a wind, not a breeze, not a gust of any kind. It is something woven into the very fabric of space. Scientists discovered it by noticing that galaxies far away from us aren't just drifting outward. They're drifting outward faster and faster over time, like lanterns floating on a dark sea whose currents slowly strengthen. This outward push is difficult to describe because it is not caused by anything visible or tangible. It is simply the nature of space to stretch, as though the universe is quietly exhaling in every direction at once. To make this easier to imagine, picture a soft piece of cloth gently expanding. Little embroidered patterns, stars and galaxies, are stitched into the fabric. As the cloth stretches, the patterns drift apart, not because they are walking or sliding, but because the fabric beneath them is lengthening. This slow stretching is happening everywhere, even in the spaces between the words you're hearing now, though on scales so tiny we cannot feel it in our daily lives. Understanding the tug-of-war between these two forces, gravity gathering in, the cosmic push spreading things out, is essential if we hope to determine how the universe might one day end. Their interplay has guided the universe for billions of years, and whatever story awaits in the distant future will depend on which force has the greater patience. Gravity behaves in a way that feels familiar. As the universe expands, the matter inside it becomes more spread out, and gravity's collective pull grows weaker. It's like stretching a net. Each knot is farther away from the next, and the ability of the net to pull inward becomes less effective. Meanwhile, the cosmic push doesn't thin out as the universe grows. It stays steady, like a quiet whisper that never fades. If the push remains constant, eventually it overtakes gravity in a very effortless way, leaving galaxies too far apart to gather and eventually allowing the universe to drift into a long, cold quiet. There is also the possibility that this outward push might not remain steady. It could grow stronger with time, like a tide that gradually rises, or it could weaken, like a breeze fading just after sunset. Our predictions of the universe's fate hinge on this small, delicate uncertainty. If the push grows very strong, it may stretch the cosmos so intensely that everything, from galaxies to atoms, becomes undone. But if it weakens someday, gravity may reclaim its influence, drawing the universe inward for a final sweeping contraction. It may help to think of these possibilities like balancing a feather on your finger. If you nudge the feather slightly in one direction, it drifts gracefully toward one outcome. If you nudge it the other way, it leans into a completely different motion. The universe, in its vastness, responds to similarly tiny nudges. A small difference in how strongly the cosmic push acts today could lead to a dramatically different future trillions or even quintillions of years from now. These differences are so subtle that even our most precise instruments need extraordinary care to measure them. To explore this balance further, imagine you're walking toward a gentle hill on a quiet morning. You can't quite see what lies over the top. If you climb slightly to the left, you might reach a meadow. If you climb slightly to the right, you might reach a forest. The slope looks nearly identical from where you stand, yet the destinations beyond the crest differ completely. In much the same way, the universe appears to be approaching a turning point, a threshold where tiny differences in its internal pressures determine whether it expands forever, comes gently back together, or moves towards something even stranger. What makes this even more mysterious is that the outward push appears to be connected not to matter, but to empty space itself. When you remove all particles, all light, all dust, all gas, and all stars from a region, you're left with what begins to seem like nothing. But this nothing is not empty in the way an abandoned room is empty. It is more like a still pond containing hidden currents beneath its surface. Even in stillness, even in darkness, there is a character, a quiet energy that shapes everything around it. This is why predicting the universe's end isn't just a matter of observing stars and galaxies. We also have to understand the deep personality of emptiness itself, and that brings us to something fascinating. The universe is not just shaped by its visible content, it is shaped by invisible fields, hidden pressures, and subtle fluctuations that we cannot directly see, but whose fingerprints appear in how galaxies move. We detect these influences the way you might sense a breeze by watching leaves tremble, even if you cannot feel the air on your skin. In our case, the trembling leaves are distant galaxies, shifting in ways that reveal the presence of forces we are still struggling to describe. All of this leads to a quiet truth. The future of the universe depends on details we have not yet fully understood. The gatherer's strength decreases as space stretches, while the cosmic push may remain constant, or it may change ever so slightly. If that whisper becomes just a little stronger, the universe may race toward a dramatic ending. If it grows a little weaker, everything may one day fold inward, retracing its steps. And if it stays steady, the cosmos may fade gently into a long, peaceful silence. These are not the loud forces of collapsing stars or exploding galaxies. They are the softest, most patient forces in existence. And in their balance lies the story of how the universe began, how it unfolds, and how it will someday come to rest. As we drift forward, we will soon begin exploring the many ways this cosmic tug-of-war might reach its conclusion, and how each ending paints a different portrait of the universe's final moments. But for now, just hold this quiet balance in your mind, the steady pull inward, the gentle push outward, and let the thought settle softly like starlight on calm water. Imagine you're standing on a quiet shoreline just after sunset. The sky still holds a faint glow, but the daylight is slowly draining away into the horizon. You can see enough to make out the gentle curve of the waves, but with every passing moment the colours soften, then dim, and the world grows quieter. If the entire universe had an emotional tone, the far future described by heat death, the big freeze, would feel very much like this moment. A long, gentle dimming, a slow fading of warmth, an endless hush settling across the cosmos. Of all the possibilities for how the universe might end, heat death is the one scientists consider the most likely if the outward push of space continues in the same steady way it behaves today. It is not violent. It does not come with the shattering of worlds or the tearing of galaxies. Instead, it unfolds with the patience of a tide pulling back slowly from the shore. The universe becomes larger, colder, and quieter, step by step, until there is nothing left that can sparkle, burn, or move with purpose. To understand this ending, imagine the universe right now as an enormous garden full of blooming lights. Stars are the flowers, galaxies are the clusters of life, and planets are the curious small creatures that wander between them. This garden is still vibrant. Stars ignite in far-off regions, clouds of gas swirl and collapse into new suns, and planets orbit in graceful paths. But in the distant future, the garden will run out of seeds. The raw material that creates stars is slowly being used up. Every time a new star forms, a small amount of the universe's potential for brightness is spent. At some point, far beyond any time frame our minds can comfortably hold, the universe will have created its last star. Picture the final one as a small, warm ember glowing in a vast darkness. It burns because gravity gathered enough gas to ignite its core, but once this gas is exhausted, the ember cools. And when this last star dims, the universe moves into a truly quiet chapter. None of this happens quickly. The age of star formation will continue for trillions of years. Even in that distant epoch, stars will still shine gently across the cosmos, although fewer and fewer will join them. But eventually, even the longest-lived stars, small red ones that can burn for many trillions of years, will fade into darkness. Their cores will cool into compact remnants that no longer glow. The universe, which once glittered with unimaginable light, will become a place where only cold remnants drift through space, like ashes of a once roaring fire. As the universe expands, distant galaxies will slip further away, their light stretched until it becomes too faint to detect. First, neighbouring galaxies grow dim, then galaxies at the edge of sight vanish from view entirely, not because they cease to exist, but because the stretching of space carries them so far away that their light can no longer reach any observer. It is like watching lanterns float out to sea until even their faintest glimmer disappears beyond the horizon. This growing isolation is one of the most poignant aspects of the Big Freeze. Imagine, just for a moment, a far future traveller living in a remote galaxy. They would look up at their night sky and see only the stars inside their own galaxy, unaware that countless other galaxies once existed. The universe becomes not only darker, but lonelier. Eventually, even the mechanisms that allow stars to shine come to a halt. The universe's temperature drops until it is only a whisper above perfect stillness. Heat dissipates evenly across space, leaving no pockets of warmth that can be used to create movement or structure. When everything has cooled and spread out, the universe reaches a state where nothing new can form. Not stars, not planets, not even the smallest chemical reactions. In this far future world, matter exists mostly as faint, cold debris, dead stars, drifting planets, and the scattered dust of ancient galaxies. Even these remnants won't last forever. Over unimaginable spans of time, they slowly break apart. Protons, the building blocks of atoms, may eventually decay, unraveling the last of matter into delicate particles of light and energy. If protons do decay, and we still do not know for certain, it would mark the final sigh of matter as we know it. But even if matter endures, the expansion of space continues its quiet spreading. The distances between particles grow so vast that meaningful interactions become impossible. Everything becomes so diffuse, so spread out, that the universe might as well be empty. Not a dramatic emptiness, but a soft, diffused stillness, like the last traces of mist lingering in a valley long after dawn. In the very last chapter of this cosmic cooling, only black holes remain as the giants of the universe. They drift alone, reigning over vast regions of space. Yet even these titans are not eternal. Black holes slowly release their energy into the universe, through a process that can be thought of as a faint glow at their edges, their final warmth escaping into the cold around them. Over timescales that dwarf every other era, even these giants eventually disappear. When the final black hole fades, the universe enters what some call the dark era, a time without stars, without heat, without structure. It is the quietest state the universe can reach. All energy becomes evenly spread. All motion slows. All light becomes soft and uniform. There is no longer anything left that can change or evolve. This is the essence of heat death. But describing it this way might make it sound sad or bleak. Instead, try imagining it as the universe reaching a place of deep rest. After ages of creation, destruction, light and motion, the cosmos settles into a calm, peaceful silence. It's not an ending with dramatic finality. It's more like the serenity that settles over a landscape after the last embers of a campfire fade, leaving warmth only in memory. This vision is one possibility, a gentle, slow unwinding of everything. And while it is currently the most favoured scenario if the universe's outward push remains steady, it is only one chapter in the library of endings. As we continue forward, we'll explore the more dramatic fates, ones that would end the universe not with a whisper, but with sudden intensity. For now, though, let the thought of cosmic evening linger, a long day of starlight drifting softly toward its quiet rest. There are endings that arrive quietly, like dusk slipping into night, and then there are endings that come with a sudden, breathtaking force. If the heat death is a soft candle dimming in a vast room, the Big Rip is a storm, slowly rising, gathering strength, and then unraveling everything in its path. It is one of the most dramatic visions of the universe's future, a scenario where the outward push of space doesn't remain steady but grows stronger and stronger, like a tide that refuses to stop rising. To understand this ending gently, imagine that same fabric of space we spoke about earlier. Picture it spread out on a table, with tiny embroidered patterns stitched into it, stars, galaxies, clusters, planets. In the heat-death scenario, the fabric stretches slowly, evenly, like a calm hand pulling at its edges. But in the Big Rip, the stretching does not stay gentle. Instead, imagine the fabric being pulled with gradually increasing force, the tension building so subtly that you hardly notice it at first. Yet as ages pass and the pull intensifies, the threads begin to strain, then tighten, and eventually snap. The Big Rip begins with a deceptively normal-looking universe. For billions of years, galaxies drift apart, stars orbit peacefully, and planets carry on with their slow journeys around suns. Nothing seems out of the ordinary. If someone living in that far future era looked up at the sky, they might not suspect that anything unusual was happening. But beneath the surface, the outward push of space, this quiet pressure that stretches the cosmos, would be growing ever so slightly stronger. This outward push is not like wind or water or heat. It does not come from particles or waves. It is simply an intrinsic feature of space itself. If, in our thought experiment, this push becomes stronger over time, then the stretching of space accelerates, not by leaps, but by gentle increments at first. A doubling of a doubling of a doubling, steady, patient, subtle, and over billions of years, those small increments accumulate until they're no longer subtle at all. Imagine two galaxies that are gravitationally bound to each other, held together by the great gatherer we call gravity. The cosmic push pulls them apart, but gravity holds them close. This balance continues for an extremely long time, but if the outward push keeps increasing, there will come a moment when gravity can no longer keep them together. It happens slowly at first, just a slight loosening. Then, Over a long and quiet time, the galaxies drift apart. Further into the future, the same thing happens within galaxies themselves. Stars that once orbited together begin to drift. Their paths stretch, their motions shift. At first, they still remain part of a recognizable spiral or cluster, but the coherence, the shared motion of billions of stars, begins to fray. Eventually, even the gravity that holds a galaxy together is not strong enough to resist the intensifying push. The galaxy unravels. Its stars drift away into the deepening night, each one becoming a lonely traveller. The Big Rip scenario continues escalating. In the next stage, solar systems begin to come undone. Planets that once circled their stars with perfect regularity find their orbits stretching, deforming, loosening. It is not a violent process at the beginning. It is more like pulling taffy, slow, elastic, almost gentle. But as the cosmic push grows, the taffy stretches farther and farther until it reaches its breaking point. A planet that once felt the warm comfort of orbiting its star now drifts away into space, no longer held by the star's gravity. The most haunting part of this scenario is that the disruptions accelerate as the universe approaches its final moments. Just as a storm gathers force before it breaks, the intensifying push causes structures to fall apart more rapidly with each passing epoch. What took billions of years, like galaxies drifting apart, reduces to millions. What took millions falls into thousands. And as time moves closer to the very last days, things that once seemed unshakable begin to dissolve almost instantly. In the final stretch of this cosmic unraveling, stars themselves become vulnerable. Their internal balance between outward pressure and gravity is delicate. When the cosmic push becomes extremely powerful, it begins to pull at them directly. Stars that have burned steadily for trillions of years suddenly swell, distort, and come undone. Their hot gas, once held together by gravity, flows outward into space like a lantern's flame caught in a rising wind. Moments later, still speaking in cosmological terms, planets, moons, and small bodies follow. They are torn apart as the expanding space around them becomes too forceful to resist. Rocks and ice, metals and minerals, all of them stretch and separate, their bonds unable to withstand the universal pull. Then comes the most astonishing stage of all. The cosmic push reaches scales where even atoms, the tiny building blocks of everything, cannot stay together. The space between particles widens at such an extreme rate that electrons are stripped from their nuclei, and even the nuclei themselves, usually held together by one of the strongest forces in nature, begin to unravel. If heat death is the universe cooling into a silent stillness over near eternity, the Big Rip is the universe being pulled apart thread by thread until the threads themselves are no longer threads at all. But even in this dramatic imagining, it is important to remember something gentle. This scenario is not meant to frighten or unnerve. It is simply one of the possibilities that arises when we imagine what might happen if the outward push of space continues to grow stronger with time. And this remains a big if. Our current understanding of the universe does not confirm such an accelerating push beyond its steady behaviour. It only tells us that we cannot rule it out entirely. The universe is subtle, and its future depends on how this quiet pressure behaves across distant ages. What makes the Big Rip interesting is not the violence of its end, but the sensitivity of its beginning. A slight shift in the character of the cosmic push, something almost imperceptible to us, could across billions of years determine whether galaxies drift gently apart or come undone dramatically. It is a reminder of how delicate the balance of forces is, and how even tiny changes can ripple outward to shape the universe's fate. As you rest in this moment, let any unease dissolve. The Big Rip, if it ever happens, lies in a future so distant it makes the age of galaxies feel like early morning, and it's only one of several possible endings. In our next steps, we'll drift into another vision, one that imagines the universe not being torn apart but gently pulled back into itself, like a long breath reversing. For now, picture the fabric of space lying quietly, its subtle tensions hidden from our daily lives, shaping destinies far beyond our horizon. When you walk along a quiet path, you might notice how your footsteps carry you forward, one after another, until you reach a point where the path gently begins to curve back toward where you came from. The journey does not end abruptly, it turns. The forward motion slows, pauses, and reverses. In the grand imagination of cosmology, the universe itself may follow a similar rhythm, a great long journey outward that one day slows, stops, and softly drifts back inward. This possible ending is known as the Big Crunch. Where the Big Rip imagines the universe being stretched apart by an ever-strengthening push, the Big Crunch imagines the opposite, a universe where the outward expansion gradually loses momentum, perhaps because the quiet cosmic push weakens or gravity regains its patience. The future, in this view, is not an endless stretching into darkness, but a long returning, as though the universe is drawing a slow breath inward after billions of years of exhaling. To picture this gently, imagine tossing a ball into the air. It rises, slows, and comes to a moment of stillness before falling back down. The early universe expanded rapidly, much like the ball rising. Eventually, if the forces at work allow it, the expansion could slow to a stop. This is the quiet moment at the top of the arc, before the universe begins to contract. Slowly at first, then more quickly, the galaxies drift back toward each other. The idea is not new. For decades, scientists considered the Big Crunch one of the strongest candidates for the universe's final state. But then, in the late 20th century, observations revealed something surprising. The expansion of the universe was not slowing down but speeding up. It was as though the ball thrown into the air began rising faster instead of falling back down. That surprising discovery led to the idea of a cosmic push woven into the fabric of space, a push that causes distant galaxies to accelerate away from us. For a long time, this accelerating push made the Big Crunch seem unlikely, but modern observations, especially those from new instruments studying the motion of galaxies across cosmic time, have suggested something intriguing. The push might not be perfectly steady. It could be weakening ever so slightly, or it could change its character completely over long stretches of time, shifting from a gentle outward encouragement into something less persistent. Imagine a breeze at your back that slowly fades as you walk. At first, it moves you forward, but after a long while, if it continues to fade, your steps slow. With enough time, you come to a gentle stop. The fate of the universe depends on whether the cosmic push carries on forever or eventually slackens enough for gravity, the great gatherer, to take the lead again. If this happens, the universe begins to reverse its expansion. At first, it's subtle. Galaxies that were drifting apart at increasing speeds begin to slow. The growth of cosmic emptiness halts. Over extraordinary spans of time, everything begins to come closer. In the extremely distant future envisioned by the Big Crunch, galaxy clusters would slowly draw nearer, merging into giant structures. Stars from distant realms would travel toward one another, pulled by the collective gravity of the universe collapsing back in on itself. The night sky would look different. Over unimaginable ages it would grow brighter rather than dimmer. Galaxies that once slipped from view would return, approaching with increasing speed. The cosmic tapestry, once stretched thin across vast distances, would begin to gather into a denser and denser weave. As the contraction accelerates, space itself warms. The glow of the universe intensifies, not from stars alone, but from the compression of matter and radiation. Picture a soft, dark blanket being folded repeatedly into a tighter and tighter bundle, the warmth building gently beneath your palms. That warmth is the universe heating up as everything draws inward. Eventually, in the distant future, the cosmos could reach a point where the density and temperature become so great that the structures we recognize begin to break down. Galaxies collapse, stars collide, atoms shatter, and everything becomes part of an increasingly hot and bright cosmic soup, a mirror image of the early universe, but unfolding in reverse order. If this collapse continues, the universe may shrink all the way down to a state of incredible density and heat, a final, fiery moment before everything returns to a single, intense point. This is the classic vision of the Big Crunch, the universe ending much as it began, not with a soft fading, but with a roaring crescendo of energy. But there is a gentler possibility nested inside this dramatic ending, a rebirth rather than a full stop. This idea is sometimes called the Big Bounce. Picture the universe collapsing inward until it reaches a moment of ultimate closeness and heat. Then, instead of stopping forever, imagine that moment acting like the compressed spring of the cosmos. The instant of pressure triggers a new expansion, a fresh breath out, launching a brand new universe with new stars, new galaxies, and perhaps new forms of life. In this picture, the universe does not die, but cycles through endless ages, each beginning with a new rising of cosmic light. To understand the Big Bounce gently, imagine blowing a soap bubble. For a while it expands, shimmering with colour. Then it reaches a point where the surface tension matches the outward breath. If the bubble were somehow elastic enough, it might contract inward for a moment, then reinflate into a new bubble with the same shimmering glow. In some theories of cosmic beginnings, the universe behaves in a similar way, expanding, contracting, and expanding again over and over. The Big Crunch and the Big Bounce both depend on the subtle behaviour of the cosmic push. If this push stays strong and steady, the universe likely expands forever. But if it changes its mind, even a tiny bit, the entire cosmic story could shift. A barely perceptible weakening over billions of years could lead to a distant future where the universe turns back toward itself like a tide retreating from a shore. These ideas illustrate how sensitive the universe's fate is to the balance of forces that shaped it from the beginning. A whisper more or less of the cosmic push, a barely measurable change in the universe's internal energy, a subtle shift in how space stretches or relaxes across vast distances. These small details could determine whether everything ends with a cold fade, a violent tearing, or a slow contraction toward a future rebirth. And so, the Big Crunch remains a poetic possibility. It is both an ending and, in some visions, a beginning waiting to unfold. It reminds us that the universe might have its own rhythms, its own cycles, its own breaths that span across eons. As we continue deeper into these possibilities, we'll soon explore a stranger ending, one that arrives not with a slow return or a gentle fade, but with a sudden and silent wave. For now, let the image linger in your mind, a universe drifting outward, slowing over long ages, pausing, and then softly folding back toward the place where everything began. Some endings move toward us slowly, like twilight deepening over a quiet field. Others approach with rising intensity, like a storm gathering on the horizon. But there is one possibility, one of the strangest and most delicate in all of cosmology, that arrives without warning, without build-up, and without sound. It is known informally as the Big Slurp, but more formally as vacuum decay. And despite its dramatic implications, it is in many ways the gentlest to describe, because it asks us to imagine not destruction, but transformation, an abrupt change in the universe's rules, unfolding in perfect silence. To understand this scenario softly, imagine a perfectly calm pond. Most of the surface is still, a mirror reflecting the sky. Now picture, somewhere on that surface, a single, tiny bubble forming, so small you might not even notice it unless you were very close. That bubble contains water in a slightly different state from the rest of the pond. The moment it appears, it begins to spread outward in a widening circle. Not because the bubble is violent, but because this new state of the water is, in a sense, more comfortable. It is the pond settling into a deeper calm. Vacuum decay is a similar idea, played out not on the surface of water, but in the fabric of the universe itself. In physics, what we call empty space is not empty in the way a quiet room is empty. It is more like a field with hidden energy, an energy that may not be in its absolute lowest state. If space is like a landscape, we may be standing in a broad valley that feels stable, yet is not the valley at the very bottom. Somewhere below us, there could be a deeper valley, one the universe hasn't reached yet. This higher valley is what physicists call a false vacuum, a kind of temporary resting place. The lower valley is the true vacuum, a more stable state. Moving from one to the other isn't something that happens over millions of years. It's more like a sudden drop, a shift as dramatic as ice melting instantly or water freezing in a heartbeat. But because this shift involves the very structure of empty space, it would not give any warning. One moment, space has one set of physical rules. In the next, it has another. To imagine this softly, picture yourself standing in a tranquil meadow on a quiet morning. The air is cool, the grass is still, everything feels peaceful. Then, in a far-off corner of the meadow, so far away you cannot see it, a small circle of ground becomes even more peaceful, a little more naturally stable. This new patch begins to grow, spreading outward smoothly and silently. The grass doesn't burn, the trees don't fall. Everything within the expanding circle simply adjusts to the new, deeper calm. From your perspective, the edge of this circle moves so quickly you would never see it coming. Then with no sound at all, you would simply find yourself inside it. In the language of cosmology, the expanding circle is a bubble of true vacuum. Once it forms, it grows at nearly the speed of light. That means no signal, no measurement, no device, even if we built instruments capable of looking across the universe, could warn us in advance. The bubble would sweep through everything silently, carrying a new version of physical reality within it. Inside the bubble, the universe might have different constants. Light might behave differently. Forces that hold atoms together might change in strength. The rules of chemistry could be unrecognizable. Stars might not form in the same way. Matter could reorganize itself into new configurations we cannot easily picture. This is not destruction in the familiar sense. It is more like a sudden rewriting of the universe's blueprint. Everything we know, atoms, molecules, stars, galaxies, depends on the current cosmic rules. A shift in those rules means a universe that reorganizes itself instantly into something new. Despite how dramatic this sounds, the most striking feature of vacuum decay is its utter quiet. There is no explosion, no collapse, no shattering of matter. The bubble's boundary travels so quickly that nothing inside it experiences any sensation. There is no fear, no warning, no anticipation. It is simply a transition from one cosmic state to another. What makes this possibility scientifically fascinating is that it arises from the mathematics of fields, those invisible smooth entities that define how particles behave. Yet for our purposes tonight, it is enough to picture the universe's empty space as a fabric that may not be at its final resting point. Most of the time it behaves consistently and predictably, but deep within the quantum world, the realm of the unimaginably small, where particles appear and vanish like fleeting whispers, there is always a tiny chance that a bubble of lower energy space could appear. If it does, the universe will follow it, sliding gently into a new configuration. And this is where prediction becomes impossible. Unlike the big freeze, the big rip, or the big crunch, vacuum decay cannot be forecasted. There is no cosmic rhythm leading up to it, no subtle turning of the tide. Even if the universe were destined to undergo this shift, the moment it happens would be forever hidden from any observer until the very instant the transition occurred. It is one of the few endings where our most advanced theories say, quite plainly, we cannot know when. This unpredictability is not a failure of science. It is simply a natural consequence of the universe's deepest layers, places where randomness is woven into the fabric of existence. Just as a raindrop might fall from a cloud at one moment instead of another, for reasons too subtle to trace, the universe itself may shift into a new state at a moment ruled by chance. This does not make the universe fragile, it simply makes it mysterious. From a human perspective, this scenario is so distant and so abstract that it does not raise fear. The timescales involved stretch beyond all imagination. Even if such a bubble could appear somewhere in the universe, the likelihood within our lifetimes, or even within the entire lifespan of stars, is extraordinarily small. For the purposes of our nightly reflections, this possibility serves not as a warning, but as a reminder of the strangeness and richness of reality. The universe is not just a vast stage of stars and galaxies. It is also a quiet ocean of invisible rules and hidden potentials, shifting and humming beneath everything we see. As we move forward, we'll explore another possible ending, one that takes place in a universe emptied not by sudden transformation, but by time itself. But for now, let the image of that silent wave drift through your thoughts, a bubble of deeper calm sliding across the cosmos, gentle, quiet, and entirely beyond prediction. If you imagine the universe as a grand story written across billions of years, black holes appear not as villains or monsters, but as ancient kings, quiet, powerful, and endlessly patient. They sit at the centres of galaxies, shaping the paths of stars, sculpting the flow of cosmic gas, and holding together the luminous spirals that fill our night sky. And in the far future, long after stars have dimmed and galaxies have drifted apart, these ancient kings may become the last rulers of the cosmos, presiding over a universe that has grown cold and quiet. To understand this distant era gently, imagine yourself in an enormous library long after closing time. The lamps have been extinguished, the halls have grown still, and the only remaining warmth comes from a few glowing embers in a fireplace. Black holes are like these embers. Even when everything around them has faded, they remain dense, silent, and enduring. In the familiar universe of today, black holes exist in many sizes. Some are formed when massive stars collapse at the end of their lives, leaving behind small but incredibly dense remnants. Others grow far larger, sitting at the hearts of galaxies and pulling in gas and stars over millions of years, becoming giants that outweigh millions or even billions of suns. These enormous black holes, with their immense gravitational pull, act as anchors for galaxies, shaping their structure and guiding the motion of countless stars. But in the long, long future, so distant that the timescales blur beyond imagination, the universe will change. Star formation will slow, then cease. Existing stars will cool into dark remnants. Galaxies will drift apart across an ever-expanding ocean of space. And in that deep future, black holes will remain the dominant structures, isolated but enduring. Imagine a sky with no stars, only the faint afterglow of ancient radiation, with black holes drifting like dark, heavy islands in an immeasurable sea. Even though black holes are associated with darkness, something surprising happens when we look closely at their edges. Over immense spans of time, black holes are not perfectly silent. They release tiny, soft glimmers of energy, a kind of whisper, through a process that can be thought of as a faint shimmering at their boundaries. It isn't the glow of a star or the flare of a supernova. It is slow, subtle, and gentle, like the warm sigh of an ember losing its last heat. This gradual release of energy is the process through which black holes eventually fade. To imagine this, picture a snowflake melting under the light of a distant lamp. It doesn't vanish suddenly. Its edges soften first. Then the delicate shapes begin to blur and little droplets appear. Eventually, after a very long time, the snowflake is gone, having released its form back into the surrounding air. Black holes fade in a similar manner, slowly releasing their energy into space over staggering lengths of time. This fading is incredibly gradual. A black hole the size of a large star might take more years to evaporate than the age of the universe so far. A supermassive black hole, like the one at the centre of our own galaxy, would take so many years to fade that the number itself becomes almost incomprehensible, a string of zeros, so long it would stretch beyond any scale we're familiar with. Yet even this enormous timescale is part of the universe's far future, written into the quiet rhythm of cosmic time. As black holes evaporate, the universe enters new stages of stillness. Once the last stars fade and the last galaxies drift apart, the future becomes an era defined by these giants slowly releasing their energy into the surrounding dark. Space grows even more empty. The leftover particles that once danced in warm clouds of gas become sparse, isolated, and cold. The universe becomes a place where the distances between meaningful events are so large that it might take longer than the lifespan of entire galaxies for anything notable to occur. There is a kind of solemn beauty in this image. The universe is not ending abruptly or violently, but settling into a profound rest. The great structures that once shaped the cosmos are fading with patience, allowing their remaining energy to drift gently outward. It is a universe that has lived a full life, formed stars, nurtured galaxies, sculpted worlds, and hosted countless cycles of creation and destruction, now easing into its final quiet phase. When the final black hole evaporates, the universe reaches a state that some describe as the dim silence. All the energy that once formed stars, planets, galaxies, and living beings is now spread thin throughout space. It is not gone. It is simply so evenly distributed that nothing new can form. There are no bright points left, no gravitational wells, no pockets of warmth or structure. Everything is smooth, quiet, and still. This might sound bleak, but it can also be seen as peaceful. The universe has undergone countless transformations of immense scale. It has seen bursts of creation that lit up the darkness, collisions that reshaped galaxies, and long ages of starlight. To reach a final rest after such a journey is not a collapse, but a calm exhale, a release into perfect balance. Black holes, as the final guardians of the cosmos, play a central role in this ending. They represent the universe's last strongholds of gravity, the final places where energy gathers before dissolving into the surrounding quiet. Their long lives reveal the incredible depth of cosmic time, reminding us that the universe's story spans far beyond the lifespan of stars, far beyond the civilizations that might come and go, far beyond the limits of what our minds can easily hold. And yet here we are, alive in a moment when black holes still shape galaxies, when stars still shine, and when worlds like ours still circle warm suns. It is astonishing to remember that we exist not in the final stages of the universe, but in a bright, lively chapter. The sky above us still glows with starlight that has travelled across space for millions of years. The great ancient kings of the cosmos are still active, gathering matter and sculpting galaxies, far from their distant future solitude. As we drift further into our exploration of cosmic endings, we'll begin to see how these enormous timescales and gentle fades fit into the larger question at the heart of our journey. Can we predict how the universe's story will conclude? For now, let this picture rest quietly in your thoughts. The universe cooling, settling, and releasing itself into an age where even black holes grow tired and dissolve, leaving behind only the softest whisper of their once immense presence. When you stand outside on a breezy afternoon and feel the wind brushing along your skin, you might easily guess whether the next hour will bring sunlight, a drizzle, or perhaps clouds drifting lazily across the sky. But try imagining what the weather might be a year from now, or 1,000 years, or 1,000,000. Each small uncertainty in today's air, each unmeasured shift in pressure, each tiny eddy in a stream of wind grows and spreads until the forecast becomes nothing more than a poetic guess. Predicting the distant future of the universe works in a similar way, only instead of clouds and wind, we track expanding galaxies, fading starlight, and the soft stretching of space itself. The universe is enormous, but the information we have about it is delicate. When astronomers measure the ways galaxies move, or how ancient light drifts across space, they are trying to read the faintest hints of a story still unfolding. The difficulty is that these measurements, as precise as they are, always come with a little room for uncertainty. Small ripples, slight variations, quiet imperfections. And across billions of years, these tiny uncertainties can grow into immense differences in how the universe might one day end. To imagine this gently, picture yourself sitting beside a calm pond. You toss a pebble into the water and watch the ripple spread outward. At first, the shape of the ripple is perfectly clear. But as it moves further away, the pattern becomes easier to disturb. A passing breeze, a dragonfly landing nearby, even the faint shifting of the pond beneath the sunlight can alter that ripple. If someone far across the pond tried to predict your ripple's shape from just a single moment near its beginning, they would struggle. The ripple carries a story, but that story is constantly influenced by tiny, unpredictable motions around it. Our understanding of the universe's expansion works in a similar way. For more than a century, astronomers have carefully measured how galaxies recede from one another, each measurement like a small note added to a growing cosmic symphony. This drifting apart of galaxies tells us about the strength of the outward push woven into space, and it tells us how the rhythm of the universe is changing over time. But even with all our instruments, delicately tuned telescopes, satellites orbiting Earth, sensors measuring ancient starlight, the story remains fuzzy at the edges. It is like trying to understand the fate of the ocean from a single ripple drifting across its surface. One challenge lies in the sheer scale of cosmic time. The universe has been expanding for more than 13 billion years. Predicting what might happen in another billion, or 10 billion, or a trillion years is like trying to predict how a mountain will look after 1,000 lifetimes of gentle rainfall. Even if we know the shape of the mountain today with great precision, small uncertainties in the erosion, the weather, or the shifting earth beneath it can generate enormous differences in the mountain's future form. Another challenge is that the universe is not a static thing. Its expansion is not a simple, steady drift. It changes subtly over time, sometimes slowing, sometimes seeming to speed up, influenced by the quiet interplay of gravity and the mysterious energy that stretches space. We cannot simply measure the expansion today, draw a neat line forward, and call that the universe's fate. The future depends on how the cosmic forces evolve, and those evolutions are still wrapped in mystery. Consider something close to home, predicting the orbit of a single leaf floating down a river. For a moment, the leaf moves one way, then it spins. A tiny swirl of water pushes it sideways. A faint current hidden beneath the surface nudges it again. Each shift, though small, changes the final path the leaf will take. Predicting the end of that path requires knowing not just where the leaf is, but how every ripple, current, and swirl will behave, and that is more information than we can ever fully grasp. In the same way, predicting the universe's ultimate fate requires knowing how every subtle cosmic influence will behave over unimaginable spans of time. Even small uncertainties in our measurements, the exact brightness of a distant star, the slight distortion of ancient light, the precise speed of a far-off galaxy, might become enormous uncertainties when projected into a future that stretches beyond all familiar timescales. Some measurements challenge our predictions more directly. When astronomers use different methods to measure how quickly the universe is expanding today, the results sometimes disagree. One set of observations reads one speed, another reads a slightly faster or slower speed. This disagreement is often described as two clocks telling different times. Both clocks are built carefully, both are reliable in their own ways, and yet they refuse to agree. This subtle mismatch blurs our understanding of how the universe's expansion behaved in the past, and therefore blurs our predictions of how it will behave in the future. Even small disagreements like this can ripple outward into vastly different possibilities. Imagine two travellers setting off across a desert. One wanders slightly more north than the other. At first, the difference seems small, just a few steps. But as they walk for days, then weeks, then months, the gap between them grows wider and wider. Eventually, the two travellers end up in entirely different landscapes, despite starting with only the slightest difference in direction. Cosmic predictions behave just like these travellers. If our measurements are even slightly off today, off by barely perceptible amounts, then the universe of the distant future could look completely different from what we imagine. One future might be a peaceful fading of stars and galaxies, another a sudden cosmic unraveling, another a long collapse toward a rebirth. Each future depends on tiny details that remain uncertain. And even if our measurements were perfect, even if we understood the expansion of space with exquisite precision, the universe itself contains elements that simply cannot be predicted with full certainty. Quantum events, those quiet tremors in the deepest layers of reality, introduce a degree of unpredictability that no instrument can eliminate. In most cases, these fluctuations are so subtle that they have no visible effect on our world. But when we project the universe forward by trillions of years, even the tiniest uncertainties can leave their mark. All of this reminds us of a simple truth. The universe is not an object we hold in our hands and examine from all sides. We glimpse it through small windows, always from a distance. Our understanding of its future comes from soft clues, faint signals, and delicate measurements woven together into a tapestry of possibilities. Predicting the universe's end is like trying to read the story of an entire ocean from a single ripple. You can see hints of where it might go, but never the full path. And far from being disappointing, this uncertainty carries its own beauty. It means the universe is still full of mystery. It means our curiosity still has room to grow. It means the story of the cosmos continues to surprise us, even after all these years. As we drift forward, we will explore one of the deepest mysteries shaping these uncertainties, the quiet, invisible push of dark energy, and how its true nature may hold the key to whatever ending awaits. Imagine standing on a quiet beach at dawn. The tide is low, the waves gentle, and the ocean seems almost asleep. As you watch, you notice something subtle. The waterline slowly shifts, inching forward or backward. It moves so gradually that you might never see the motion directly, only the result. Dark energy is like that shifting tide, a quiet, nearly invisible influence gently guiding the universe in ways we barely perceive, yet completely depend on to understand our cosmic future. Dark energy is one of the most mysterious ideas in all of science. It isn't a substance we can touch or a force we can see. Instead, it behaves like a soft pressure woven into the fabric of space. Everywhere you go, between galaxies, between stars, even between particles, the fabric carries this faint, persistent push. It is so delicate that it does nothing noticeable on human scales, yet so influential that it shapes the fate of the entire universe. To imagine dark energy more gently, picture the universe as a vast, flexible sheet. Galaxies are like painted dots on that sheet. If the sheet stretches, the dots drift apart. In the early universe, the stretching was driven mainly by the energy left over from the beginning of time, but as the universe expanded and thinned out, that leftover energy weakened, while the subtle push from dark energy began to dominate. Now, billions of years later, the expansion of the universe is controlled mostly by this quiet, ever-present pressure. The astonishing part is that we still do not know what dark energy truly is. We know it acts like a push. We know it fills space uniformly. We know it does not weaken as space expands. But the deeper nature of this phenomenon remains hidden. It is like hearing a soft humming in the walls of a house you've lived in your whole life, yet never finding its source. This mystery leads to a profound question. Is dark energy steady and unchanging, or does it evolve over time? The answer could determine the fate of everything that exists. If the quiet push of dark energy remains steady, never growing stronger or weaker, then the universe will likely drift toward a fate of gradual cooling and dimming. Stars will burn out, galaxies will drift apart, and the cosmos will settle into an endless, peaceful stillness. This is the gentle fading we explored earlier, the heat death. But if dark energy grows stronger with time, even slightly, then we approach a different future, a future where the stretching becomes overwhelming, leading eventually to a universe torn apart by its own expansion. In that scenario, galaxies unravel, stars lose their stability, planets drift free, and even atoms may one day be pulled apart. This is the dramatic vision of the Big Rip. And if dark energy weakens, then gravity, the great gatherer, might one day reclaim control. The universe could slow its expansion, stop, and then begin to contract. Over unimaginable stretches of time, galaxies would move closer, stars would grow brighter as the cosmos compresses, and the universe could end in a brilliant, fiery collapse known as the Big Crunch. In some visions of this ending, that collapse becomes the seed of a new universe, a big bounce, leading to a new beginning. The delicate question is, which path will our universe follow? Recent observations have added new layers to this puzzle. Projects like decay, which map the positions of galaxies across billions of years of cosmic history, and telescopes like the James Webb Space Telescope, which peers deep into the universe's past, are uncovering clues that the cosmic push might not be perfectly constant. Some early findings suggest slight hints, just hints, that the universe's expansion rate might have been different at different times in ways we didn't expect. It is as though the tide we thought was steady might actually swell and recede in ways too subtle to see from the shore. These shifts are small, so small we cannot yet say for sure whether they're real or simply faint quirks in the data. But if they are real, then the universe's fate might be more flexible, more changeable, and more surprising than our earlier models imagined. To make this more relatable, imagine watching a distant lantern drifting on the surface of a lake. If you measure its drift carefully over hours, you might see that it moves steadily away from you. But if you watch over days, you might notice that the drift is not perfectly steady. Sometimes it accelerates, sometimes it slows. You can't predict the lantern's ultimate path unless you know the full story of the currents beneath the surface. Dark energy behaves in much the same way. We see the lanterns, galaxies drifting, but we do not yet fully understand the currents. Some theories describe dark energy as something like a slowly shifting field, almost like a delicate mist that changes density in ways too subtle for us to measure directly. If this mist thins out over time, the cosmic push could weaken, leaning the universe gently toward a future collapse. If it thickens, it could lead to a future of endless expansion, or a catastrophic tearing. And if it remains steady, the universe will glide into a long twilight of fading stars. The importance of dark energy lies not in its strength, but in its subtlety. Even a tiny change, so small that it would never affect a star, a planet, or a living being, can dramatically alter the universe's future when stretched across trillions of years. It is like a ship setting sail with a rudder angled by just a finger's width. The difference is barely noticeable at first, but across a long voyage that slight angle changes the destination entirely. This is why predicting the end of the universe is so deeply tied to understanding dark energy. It is the universe's quiet hand on the wheel, its hidden rhythm. Until we know how that rhythm behaves, whether it speeds up, slows down, or remains steady, we cannot say with certainty where the cosmos is headed. Yet there is something beautifully humbling in this uncertainty. The universe is vast beyond comprehension, and we occupy only a tiny moment within its story. The fact that we can measure the motions of galaxies, detect the faint afterglow of the early cosmos, and even begin to question the nature of the force driving its expansion is astonishing. Our understanding may be incomplete, but it is still extraordinary. As we drift forward, we will explore another piece of this cosmic puzzle: how disagreements in our measurements, the so-called two clocks that refuse to match, introduce even more mystery into our predictions. But for now, let the mystery of dark energy settle softly in your thoughts. It is the universe's quiet tide, shaping everything, yet revealing itself only in whispers. If you've ever tried to keep time using two different clocks, one on your wrist and one on the wall, you may have noticed something subtle. Even if both clocks are well made, even if both tick with reassuring precision, they sometimes drift apart. One may run a little fast, the other a little slow. For most things in everyday life, this difference doesn't matter. But if you were trying to predict the exact instant of sunrise 1,000 years from now, or calculate the path of a traveller across a continent, that quiet mismatch between clocks would become a much bigger problem. In cosmology, something similar happens when we try to measure how fast the universe is expanding. Astronomers use two main cosmic clocks. One clock reads the present-day behaviour of galaxies, how fast they move away from us right now. The other reads ancient light, a faint whisper left over from the earliest era of the universe, carrying clues from a time when the cosmos was young and tightly packed. These two clocks should agree. They are both measuring the expansion of the same universe after all. But for reasons we don't fully understand yet, they don't quite match. This mismatch is gentle, only a few % difference, but it matters deeply. It's like two navigators charting the same ocean currents and arriving at slightly different maps. If the universe is a grand journey, then knowing its speed, its rate of expansion, is essential to predicting where it will go. But if our measurements disagree, even by a small amount, our predictions for the far future become hazier, like trying to see a distant shore through soft morning fog. To make this more tangible, imagine two people watching a lantern drift across a lake. One observes it from a hilltop using a telescope to follow its path. The other rows a boat closer to the water, watching the lantern's reflection ripple across the surface. They both try to estimate how quickly the lantern moves, but their perspectives differ. The water behaves unpredictably, and the lantern's movements are influenced by currents too subtle to measure. When they compare their results later, they discover a mismatch. Not enough to make them doubt the lantern itself, but enough to make them question the precision of their measurements. Astronomers face something similar when analysing the universe. Measurements of nearby galaxies tell us how fast the universe is expanding in this moment under the conditions of the present-day cosmos. Meanwhile, measurements of the universe's oldest light, the faint glow that has travelled for billions of years, reflect how fast the universe used to expand long ago. When these two measurements disagree, it suggests that our models of how the universe evolved from then to now might be missing a subtle detail. These subtle details matter because the expansion of the universe is not a simple number. It is the result of the push and pull of cosmic forces, gravity gathering things inward, and the quiet pressure of the fabric of space itself gently stretching things outward. If our two clocks tell slightly different times, it could mean that the balance between these forces has changed in ways we didn't expect. Perhaps the cosmic push wasn't as steady as we thought. Perhaps the earliest universe behaved differently than our models assume. Or perhaps there's something deeper, some hidden aspect of reality influencing the expansion in ways we have not yet imagined. One gentle interpretation is that the universe might be subtly more complicated than the picture we've drawn. It could be that the ancient light we study is influenced by behaviours in the early cosmos that our theories don't fully capture. Or perhaps the galaxies we observe today, with their clusters and swirling motions, hide tiny biases in our measurements. These possibilities require patience. They ask us to listen more carefully, observe more deeply, and accept that uncertainty is part of the cosmic story. Another possibility, one that scientists are exploring with curiosity and caution, is that the mismatch points to new physics. Perhaps the universe contains ingredients we haven't yet identified, or perhaps space and time behave differently on scales too large or too small for our instruments to see clearly. In this interpretation, the two cosmic clocks are not wrong. They're simply responding to a universe with richer complexity than we currently assume. To appreciate the importance of this mismatch, think of a long journey across a desert. If your compass points just a tiny bit off from true north, the difference is hardly noticeable at first. But after days or weeks of walking, that small deviation leads you far from where you expected to be. In cosmic terms, the divergence between the two clocks is small now, but when we project the universe's evolution across billions or trillions of years, that small difference can lead to dramatically different destinations: heat death, big rip, big crunch, or something entirely unexpected. And yet this mismatch does not reveal its meaning easily. The more closely astronomers look, the more questions emerge. Some of the most precise measurements from nearby galaxies show the expansion proceeding slightly faster than we expect, based on early universe data. Meanwhile, the ancient light suggests a slightly slower rate. It's as if the universe were whispering two slightly different stories about its own growth. The James Webb Space Telescope, with its sharp vision into the deep past, is offering new clues. It observes ancient galaxies forming earlier, brighter, and more quickly than our models predicted. These observations hint that the early universe might have been more dynamic, more active, or more complex than we previously imagined. If so, it is no surprise that our two clocks might disagree. They may each be telling part of a bigger, richer story. This mismatch is often described as one of the most fascinating puzzles in modern cosmology, not because it threatens our understanding, but because it suggests we're on the edge of discovery. The universe is not a solved equation or a closed book. It is a living mystery. The slight disagreement between clocks invites us to look deeper, to refine our tools, and to approach cosmic questions with both humility and wonder. And in the context of our journey tonight, this uncertainty has a profound implication. If we cannot measure the universe's expansion perfectly today, then predicting its ending millions or trillions of years from now becomes inherently uncertain. Our best forecasts rely on understanding the present moment with exquisite clarity. If our two cosmic clocks disagree even slightly, then the paths into the far future diverge just as subtly, leading us toward futures that are possible but not guaranteed. Yet there is peace in this uncertainty. It means the universe remains full of room for imagination. It means our predictions are poetic approximations rather than rigid conclusions. It means the cosmos still holds secrets waiting to be uncovered, secrets that may reshape our understanding of space, time, and destiny. As we drift onward, we'll gently explore one more layer of unpredictability, the whispers of quantum possibility that ripple beneath everything, adding mystery to even the most carefully drawn predictions. But for now, let the image settle. Two clocks ticking in the grand silence of the cosmos, almost in harmony, but not quite. And in that gentle difference lies a universe of questions. If you've ever watched dust floating in a beam of sunlight, you know how unpredictable those tiny particles can be. They drift one way, then pause, then flutter in another direction for no obvious reason. Even the faintest movement of air, too subtle for you to feel, nudges them along. In the realm of the very small, unpredictability is not a mistake or a glitch. It's a fundamental feature. And in a curious, gentle way, the same unpredictability echoes through the entire universe. Beneath the grand sweep of galaxies and the slow drifting of cosmic expansion lies a deeper layer of reality, a layer where events unfold not with certainty, but with possibility. This is the world of quantum behavior, where particles appear and vanish, fields soften and shimmer, and the foundation of space itself hums with quiet fluctuations. To imagine this world, think of the surface of a pond that looks smooth from a distance, but, when viewed closely, reveals endless tiny ripples, each one rising and falling with delicate spontaneity. These tiny fluctuations might seem too small to matter on cosmic scales, but over unimaginable expanses of time, even the smallest tremors can influence the shape of the universe's future. Imagine a candle flickering in a still room. The flame dances with tiny motions, none of which seem important. But if you recorded its movement for hours, you would see it subtly illuminate different parts of the room, casting shadows that shift and reshape the space in barely noticeable ways. Quantum fluctuations are like those flickers in the cosmic candlelight. When scientists speak about the uncertainty inherent in the universe, they don't mean that we lack tools or intelligence. They mean that the universe itself behaves in ways that are inherently unpredictable at the deepest level. Instead of following a strict script, reality seems to improvise moment by moment, responding to tiny disturbances that cannot be fully controlled or measured. Take the idea of vacuum decay, which we explored earlier. It's a perfect example of how quantum uncertainty shapes the universe's future. The possibility of a bubble of deeper, more stable space appearing isn't something that can be timed. It is not like waiting for water to boil or the moon to rise. It's more like waiting for a raindrop to form inside a cloud. The raindrop might appear at any moment, or not at all, for reasons too subtle to trace. This unpredictability means that if vacuum decay ever does occur, it will be a surprise. There is no countdown, no warning, no cosmic clock that tells us the time. But quantum uncertainty affects more than just exotic scenarios. Even in everyday cosmic behaviour, such as the expansion of space or the cooling of galaxies, these small fluctuations can shape the delicate details. Over trillions of years, even the gentlest nudge might steer the universe toward one ending or another. The difference between a universe that collapses, one that fades, or one that tears itself apart may hinge on subtleties in how these tiny fluctuations ripple across cosmic history. Imagine a mountain stream winding its way down a slope. In the beginning, a single drop of water might fall slightly to the left instead of the right. That small difference causes it to follow a different miniature channel, which then leads to a different path, and so on, until miles downstream it emerges in a completely different part of the valley. Quantum fluctuations act much like that tiny choice at the top of the mountain. A subtle shift that, given enough time, leads to vastly different landscapes. This raises a philosophical question that people have pondered for centuries. Does the universe follow a fixed path, or does it write its story as it goes? In the world we see around us, trees growing, rivers flowing, planets orbiting, it often feels as though everything follows rules so reliable the future is simply the unfolding of a predetermined script. But in the quantum world, the script is not fixed. It contains blank spaces, improvisations, and gentle randomness woven into the fabric of existence. For our purposes tonight, this means something profound. No matter how much we learn about cosmic expansion, dark energy, or the behaviour of galaxies, there will always be a layer of unpredictability beneath it all. The universe does not reveal its ending with perfect clarity, because the smallest elements of reality, the threads from which the cosmic tapestry is woven, do not behave with rigid certainty. They shimmer, ripple, and wander in ways that keep the future open to many possibilities. This uncertainty does not diminish the beauty of the universe. In fact, it enhances it. The cosmos is not a machine grinding toward a predetermined conclusion. It is more like a symphony where each note subtly affects the next, where tiny changes add depth, texture, and surprise. The universe contains structure and order, but also room for chance, improvisation, and novelty. Even the models we create, scientific stories that describe how the universe evolves, depend on assumptions that may change as our understanding grows. We assume that dark energy behaves a certain way, that gravity remains consistent, that matter stays stable. But these assumptions are based on what we observe now. Across trillions of years, these assumptions may shift, soften, or transform, opening new doors to unfamiliar futures. This does not mean the universe is unknowable. Rather, it means our knowledge comes in layers. The outer layers, like the behaviour of galaxies and stars, are clearer. The deeper layers, like the quiet quantum hum beneath everything, are hazier but still meaningful. Together, these layers create a picture that is not perfect, but wonderfully rich. When we talk about predicting the universe's end, we're not trying to solve a puzzle with a single right answer. We're exploring a landscape filled with branching paths, each shaped by cosmic forces and quantum whispers. Our predictions are sketches, not blueprints, gentle outlines of possible futures. As we move onward, we leave the realm of deep cosmic physics and enter a softer, more human territory. knowing that the universe might end in many possible ways, some gentle, some dramatic, some unknowable. What does that knowledge do to us? How does it shape the way we breathe, dream, or find meaning? For now, let this thought linger. The universe is threaded with unpredictability, not as a flaw, but as a quiet invitation to wonder. It may be impossible to predict its final chapter with certainty, but perhaps that uncertainty is part of what makes this moment, right here, right now, so beautifully alive. When we talk about the end of the universe, it is easy to imagine distant galaxies drifting apart, stars dimming into darkness, and black holes eventually fading into silence. These images feel remote, suspended so far beyond our own lifetimes that they seem like abstract paintings rather than pieces of a future reality. Yet even if the end lies trillions of years ahead, thinking about it touches something fragile and deeply human within us. It invites questions that reach into the quietest corners of our hearts. Imagine for a moment that you're sitting alone under a night sky far from the city. No lights, no noise, only the soft hum of insects and the endless dome of stars above. Every point of light you see is a story. The burning heart of a distant sun, the glowing cradle of a newborn star, the echo of an explosion that happened millions of years ago. The universe is vast beyond measure, yet the simple act of looking up makes us feel intimately connected to it. That connection is where this session gently begins. If someone whispered to you that the universe will one day end, whether in a slow fading, a sudden quiet wave, or a long return inward, what would you feel? Would it unsettle you? Would it bring a strange calm? Would it shift the way you breathe, dream, love, or plan your life? The question is not meant to frighten, but to invite reflection. For many people, the idea of the universe ending evokes a sense of insignificance. How small we are, how brief our lives, how fragile our moments compared to the canvas of cosmic time. Our entire species, our histories and hopes unfold within a blink of the universe's lifetime. But insignificance is only one way of seeing it. Look more softly and you may find another view, one filled with awe. We are here, in this moment, on a warm and living planet orbiting a stable star in a galaxy rich with wonders. We are conscious beings capable of asking questions about our origins, our purpose, and our place in the vastness. Out of the countless particles drifting through the universe, a few have arranged themselves into the shape of you, someone who can contemplate starlight, feel love, and seek understanding. That is extraordinary. When we consider the universe's eventual end, the most profound response may not be fear or sadness, but gratitude. Gratitude for existing in a chapter where stars still shine. Gratitude for a cosmos still young enough to be full of stories. Gratitude for the simple privilege of being able to look up at night and know that you are part of something unimaginably grand. Still, the human heart holds complexity. Some people might feel a melancholy tenderness, imagining distant futures where the stars fade one by one. Others might feel comfort, knowing that even the universe follows a natural arc, a beginning, a middle, and an end. Beauty often lies in impermanence, the way a flower blooms and later releases its petals, or how a sunset deepens into twilight before giving way to night. The universe, too, has its seasons. Psychologists sometimes say that understanding the end of something brings clarity to the middle. If you knew a story would one day conclude, you might savor its chapters differently. If you knew a day would fade, you might cherish its sunlight more deeply. In the same way, contemplating the universe's distant ending can bring a soft focus to our lives. It reminds us that our time is precious, not because it is short on a cosmic scale, but because it exists at all. Some people might wonder, Why think about the end of the universe when it is so far away? Because the act of imagining it changes us. It places our worries, our ambitions, our fears into a perspective so broad that it reshapes them. Suddenly, the arguments we had, the deadlines we stress over, the involuntary rush of our days take on a gentler tone. When viewed against the backdrop of galaxies drifting through ancient darkness, our burdens seem lighter and our joys seem brighter. There is also a kind of quiet empowerment in recognizing that the universe will end someday. Not because we can change it lies far beyond our influence, but because it reminds us that the meaning of our lives does not depend on endless time. Meaning emerges from presence, from awareness, from connection, from the way we choose to love and create and wonder within the moment we have. Some may feel a flicker of sadness knowing that all stories eventually conclude, but endings, cosmic or personal, do not erase the value of what came before. A beautiful melody does not become meaningless because it eventually falls silent. A sunrise is not diminished because night follows. The beauty lies in the fleeting glow, the brief moment of warmth, the experience itself. Another perspective arises when we consider the vastness of time. The universe has existed for more than 13 billion years, and yet it is still early in its story. Stars continue to form, galaxies continue to dance, and life continues to wonder. The end, whatever shape it takes, lies far beyond the horizon of our imagination. Knowing this can create a deep, comforting space within us, a recognition that our lives are sheltered within one of the universe's most vibrant chapters. As we continue forward in our exploration, we will soon step beyond the personal heart and into the collective mind, into humanity's shared response to cosmic knowledge. But before we do, take a moment to breathe softly. Feel the rise and fall of your chest, the steady presence of the room around you, the quiet rhythm of your thoughts. You're a brief spark in the darkness, yes, but a spark that can feel, reflect, and marvel. And that is no small thing. The end of the universe may lie in unimaginable distances of time, but the meaning of our lives lies here, in the present moment, illuminated by the stars that still burn above us. When a person first hears that the universe will one day end, not soon, not in any time frame that touches human history, but someday, a quiet question often rises to the surface. What should we do with this knowledge? Not as individuals, but as a species. The universe's future stretches beyond imagination, yet its distant ending gently echoes back into the present, influencing how we think, create, dream, and discover. Humanity has always lived with a sense of endings. Civilizations rise and fall, stories begin and conclude, lives start with a heartbeat and end with a final breath. And yet, when we extend our imagination beyond our personal lifetimes and consider the universe's final chapters, the scale becomes so immense that it slips out of the realm of fear and into the realm of wonder. The question turns from how will everything end to what do we do, knowing the ending is out there, somewhere in the vast dark? One possible response is despair, but despair has never been humanity's natural resting place. Even in the face of uncertainty, we tend to move toward curiosity, creativity, and meaning. If anything, contemplating the universe's fate often deepens our resolve to explore and understand. It encourages us to see knowledge not as a burden, but as a lantern, lighting the path through the unknown. Imagine humanity several centuries from now, still gazing at the stars, but with tools far more advanced than our own. Perhaps we've built observatories orbiting quiet moons, or telescopes perched at the edges of our solar system, far from the sun's glow. Perhaps we've found ways to travel between planets with ease, or even reach to neighbouring stars. In such a future, the knowledge that the universe may one day fade could become a motivating force, fueling our desire to explore, to preserve, to leave traces of our existence scattered like gentle footprints across the cosmic shore. Some thinkers imagine humanity building archives, quiet cosmic libraries drifting through space, carrying the history of Earth and its species, waiting for future civilizations to discover. Not as warnings, but as gifts. These archives might contain stories, art, music, languages, scientific discoveries, fragments of what it meant to be human. They would not fight the end of the universe, nor try to outlive it, but simply honour the beauty of existence by preserving memory. Others imagine humanity reaching outward with ambition, driven by creativity rather than fear. Interstellar travel, once a dream, could become a necessity, not to escape an ending trillions of years away, but to explore the vast tapestry of worlds that lie waiting in the darkness. If the future contains a long fade, perhaps our descendants will spend their days exploring distant galaxies, each one a chapter in the cosmic book. If the universe is destined for a fiery collapse, perhaps they will seek to understand the deep physics guiding that return. And if the universe contains cycles of rebirth, humanity may one day witness the dawn of a new cosmic age. But beyond technology and exploration, there is something deeper in humanity's potential response, something emotional, cultural, and spiritual. Every culture on Earth has its own wisdom, its own myths, its own stories about beginnings and endings. Some speak of rebirth, others speak of return. Some imagine creation emerging from emptiness. Others see the universe as an endless cycle of transformations. The idea of a cosmic ending does not erase these stories. Instead, it expands them, offering a new layer of reflection. If we knew the universe would one day fade, how might that knowledge reshape our philosophies? Perhaps it would soften our disagreements, reminding us that we share not only a planet but a fleeting moment of cosmic daylight. Perhaps it would inspire a deeper sense of interconnectedness, pushing us to care for one another, knowing that our lives, short though they may be, are threads woven into a tapestry far older and larger than ourselves. Some people might respond with a sense of urgency, a quiet realization that time is precious. This urgency does not come from fear, but from appreciation. If time is finite, even on a cosmic scale, then meaning becomes brighter, not dimmer. Our decisions gain weight, our friendships deepen, our art becomes a celebration of impermanence, like a sand mandala carefully crafted and then released back into the wind. Others might find comfort in the thought that the universe is part of a natural cycle. Just as stars are born, burn, and eventually fade, perhaps the universe's own life cycle is simply another part of existence, a rhythm that echoes through all things. Knowing this can make the ending feel less like a loss and more like a transformation, a transition into something new. Technologically, the idea of the universe's ending has inspired imaginative concepts. Star machines harvesting energy from dying stars, vast structures drifting through intergalactic space, and cosmic arcs designed to carry life far beyond the boundaries of its original home. While many of these ideas remain dreams for now, they reveal something deeply human: our instinct to preserve, to explore, to endure. Even if none of these dreams are realized, the mere act of imagining them brings value. It forces us to think beyond our immediate concerns, beyond political cycles, beyond lifetimes, beyond civilizations. It encourages us to imagine humanity not as a temporary spark, but as a species capable of curiosity without limit. And that curiosity may be our greatest gift. Even though we can't predict the universe's ending with certainty, Our desire to understand it reveals something profound about us. It shows that we carry within us a longing to reach beyond ourselves, to make sense of the infinite, to connect with the stars in ways both literal and symbolic. As we drift toward the next part of our journey, we move from humanity's emotional responses into the quieter realm of ethics. If we could predict the universe's end, whether through slow fading, sudden transformation, or cyclical rebirth, would we have a responsibility to tell the future? Would warning matter? Or would it simply be a reminder that endings, like beginnings, are part of the cosmic cycle? Before we explore those questions, take a moment to feel the weightlessness of this thought. Humanity is a small species on a small planet, yet our minds reach to the edge of time itself, and that alone is extraordinary. There is a quiet moment that happens when someone receives news that changes the way they see their life. Sometimes that news is joyful, sometimes it's heavy, and sometimes it simply opens a door to deeper reflection. In the same way, imagining that we could predict the universe's end, whether through slow cooling, sudden transformation, or a grand cosmic return, brings with it not only scientific curiosity, but also ethical questions that rest gently at the edge of philosophy. If humanity ever reached a point where we could foresee the universe's final chapter with clarity, what should we do with that knowledge? Would we share it freely, like a story meant for everyone? Or handle it carefully, the way one holds a delicate piece of glass, mindful of how it might affect the minds and hearts of others? At first glance, the answer seems obvious. Truth should be shared. Knowledge belongs to all of us, especially when it concerns something as universal as the fate of existence itself. But when you look more closely, the question becomes more nuanced, because knowledge, even when true, is not always simple. It carries weight. It shapes emotions, hopes, and choices, and the deeper the truth, the deeper its ripples. Imagine a future civilization that can measure cosmic processes with exquisite precision, so precisely that they know whether the universe will fade, collapse, or transform. What responsibility would they carry? Should they write this future into textbooks for children? Should they broadcast it across planets? Should they treat it as sacred information meant only for those prepared to reflect on it without fear? Consider how different people might respond. Some would greet the news with calm acceptance, finding comfort in the idea that the universe, like a great story, has an arc. Others might feel a new sense of urgency, wanting to create, love, and explore with more intention. But some might also feel overwhelmed, not by an immediate threat, but by the sheer vastness and inevitability of cosmic change. The knowledge would be true, yet might weigh heavily on hearts not ready for such grand scales. This is where ethics enters, the question of how knowledge should be offered and in what spirit. Humanity has faced similar dilemmas on smaller scales. When scientists first discovered natural processes that could influence life on Earth, such as the shifting of continental plates or the cycle of ice ages, these discoveries invited both curiosity and humility. They did not change anyone's daily routine, but they reshaped our understanding of the world. The end of the universe, while unimaginably distant, carries the same dual nature. It is both irrelevant to the next sunrise and deeply relevant to how we understand our place within the cosmos. If the universe is destined for a slow, silent fade, should we speak of it as a tragedy or as a moment of cosmic rest? If the universe is headed toward a collapse and rebirth, should we describe it as an ending or a beginning? If a sudden transformation lies in the far, far future, should we frame it as frightening or simply as one more chapter in a story we are privileged to witness for a short while? The framing matters. How we speak about ending shapes how we experience the middle. There is also the question of responsibility across generations. If we could predict the universe's end, not in human timescales, but in cosmic ones, should we pass that prophecy across millennia? Should civilizations millions of years from now inherit our knowledge, even if the ending lies so far beyond their own lifetimes that it might feel like inheriting a story with no moral, no urgency, no action to take? Perhaps the answer is not to warn, but simply to share gently. To know the ending is not to fear it, but to understand the preciousness of the chapter you are in. There is another layer to consider: how knowledge of the universe's ending might influence societal choices. Some cultures might treat it as a sacred mystery. Others might see it as motivation to explore, create and preserve. Some might ignore it entirely, choosing to focus on the joys and struggles of everyday life. And all of these responses would be valid. The universe's fate does not demand anything from us. It does not call for action or sacrifice. It simply exists as a distant truth, one that can either inspire wonder or be set aside in favour of more immediate concerns. But because knowledge has the power to shape meaning, humanity must handle such information with care, not by hiding it, but by offering it with gentleness, like handing someone a fragile flower rather than a stone. The truth about the universe's distant ending is too beautiful, too vast, too detached from our daily lives to be framed as doom. Instead, it can be shared as perspective, a reminder that our moment in the cosmos is rare, fleeting, and extraordinary. There is also the philosophical question of whether the universe's ending, once known, should influence our choices at all. Should it guide our ethics, our laws, our ambitions? Should it become a cornerstone of our worldview, or remain a quiet cosmic backdrop? Perhaps the answer lies in balance. The knowledge can enlighten, but it should not overshadow the richness of human experience. It can inspire humility, but not undermine purpose. It can deepen our appreciation for life, but not diminish the meaning of small joys. In this way, knowing the universe's future becomes less about prediction and more about presence. It invites us to cherish the arc of existence, to recognize the beauty of our brief spark against the dark fabric of the cosmos. It reminds us that endings, rather than diminishing meaning, enrich the experience of the present. Just as knowing that a song will eventually end makes its melody more precious, knowing the universe has an ending can make our time beneath the stars feel more intimate and profound. As we drift toward the final part of our journey, we will step away from the ethical questions and return instead to something quieter, the gift of the present moment. The universe's ending, no matter how far away, reminds us that each instant we live is part of a grand cosmic dawn, a rare and luminous chapter in the story of all things. But before we reach that final reflection, let this idea rest softly in your mind. Sometimes knowing the ending makes the middle more meaningful. Imagine waking up early in the morning, just before sunrise. The world is quiet. The sky is still dark, but there is a soft hint of blue gathering near the horizon, the first whisper of dawn preparing to brighten the day. That moment, the stillness before the light, is precious precisely because it feels like the world is just beginning. In the vast timeline of the cosmos, humanity exists in a similar kind of dawn. Even though the universe is more than 13 billion years old, it is still in one of its brightest, most vibrant chapters. Stars are still burning, galaxies are still thick with light, and planets like our own continue to orbit their warm suns. This era, filled with starlight and structure, is the universe's early afternoon. It is a time when life can flourish, when the sky is rich with stories, and when the cosmic landscape is full of movement and possibility. If the entire lifetime of the universe were compressed into a single 24-hour day, humanity would appear in the last breath before midnight, a flicker of awareness that arrives just as the cosmic day begins to soften into evening. And yet, despite being such a recent addition to the story, we've already learned to look up, to wonder, to ask questions that reach across the sky and into the deep past. This is part of the privilege of existing now. We're alive in an age when the universe is still speaking clearly, when its signals are still bright enough to read. Think of what you can see just by stepping outside on a clear night. The Milky Way cutting across the sky in a soft, glowing arc. The faint glimmer of distant stars millions or billions of years old. The steady light of planets reflecting the sun's warmth. All of these sights are possible because we live in a universe young enough that its beauty has not yet faded. Far in the future, when galaxies drift beyond visibility and the stars grow dim, the night sky will look very different. But we are here now, at a moment when the universe is offering us its full brilliance. There is something quietly miraculous about this timing. We exist in an era when heavy elements, those needed for life, have already formed inside generations of ancient stars. We have emerged after the cosmic fog cleared, but long before the starlight fades. The universe has spent billions of years preparing the conditions for life to arise, and billions more remain before the great changes of the far future begin to take shape. In this window, this gentle, luminous chapter, life has the space to look up, reflect, and wonder. Imagine for a moment that you could speak to an observer living in the far future, in a time when galaxies have drifted so far apart that the night sky contains only the faint glow of their own home galaxy. That observer might know the universe is vast, but they would never see the grand tapestry of galaxies we see today. They would never witness the Milky Way stretched across the sky, or the glow of neighbouring clusters. Their universe would feel smaller, quieter, more isolated, not because the true cosmos had grown smaller, but because so much of it had slipped out of view. We are fortunate to live in a time when the cosmos is still showing its cards. We can measure the leftover light from the early universe, map galaxies spread across billions of light years, and watch stars ignite and collapse. We can study the quiet push of dark energy, the dance of galaxies, and the hidden hearts of black holes. Our moment in time is not just comfortable for life, it is also perfect for cosmic understanding. Had we arisen earlier, the universe would have been too hot and chaotic. Had we arrived later, it would have been too dim and empty. But we exist in a golden age of visibility. There is also something deeply meaningful about living at a time when humanity is taking its first steps beyond its home world. We have sent machines to distant planets, touched the surface of the moon, and launched small emissaries into the dark beyond our solar system. These are humble steps, but they carry a significance that echoes across the cosmic timeline. We are a species learning to stretch its hands outward, to touch the vastness, to explore not only for survival but for curiosity and wonder. And this curiosity connects us to something larger. When you look at an old photograph of a galaxy taken by the James Webb Space Telescope, you're seeing light that has travelled across space for billions of years, arriving at your eyes just as it finally completes its journey. That moment, the moment when ancient light meets human consciousness, is a meeting across time. It is a handshake between the deep past and the present. This intersection of cosmic history and human awareness is a reminder that we live in a uniquely privileged chapter, not privileged in the sense of entitlement, but in the sense of timing. We exist in a cosmos that is still young enough to reveal itself, yet old enough to have matured into a place where life can arise. The universe is in its glowing season, and we are here to witness it. There is comfort in this thought. No matter how the universe ends, through cooling, collapsing, or transformation, we exist now, in a bright moment where stars burn, galaxies gather, and the night sky still sings with stories. This chapter is long enough for humanity to learn, grow, explore, and find meaning. It is long enough for civilizations to rise, for art to flourish, for friendships to form, for dreams to unfold. It is long enough for love, curiosity, and beauty to take root. And so, as we drift toward our final session, let this idea settle gently. You're alive in a universe that is still unfolding its wonders. You're a witness to a cosmic dawn that future beings may never see. The stars above you are not just distant suns. They're reminders that, in this vast timeline, you inhabit a precious moment of light. There is a moment in every long night when the world grows still. The air settles, the sounds fade, and time seems to loosen its grip, as though the universe is gently reminding you that it always carries more quiet than you could ever notice. In this final session, we drift into that stillness together, reflecting not on how the universe ends, but on what it means to live within its unfolding story, right here, right now, in the luminous space between beginnings and endings. Throughout our journey, we've explored vast cosmic possibilities, a universe fading gently into darkness, a universe torn apart by its own expansion, a universe collapsing back into brilliance, a universe transformed in an instant by a silent wave. Each possibility is rooted in science, yet softened by the understanding that none of them are imminent, none of them are threatening, and none of them diminish the meaning of our lives. Instead, they expand it, stretching our sense of perspective like soft light spreading across a horizon. If the universe will end someday, far beyond the reach of our species or any star we can name, then what does that mean for this moment? The answer, when held gently, becomes beautifully simple. This moment becomes infinitely precious. Picture yourself lying beneath a quiet sky. The stars shimmer above you, each one a tiny lantern burning in the dark. They feel eternal, and in a sense they are. Because even though stars eventually fade, the light that reaches you now is part of a continuum, a flow of illumination that links your life to moments stretching deep into the past. You're receiving messages sent across unimaginable distances, messages from stars that may no longer exist, yet still offer their light as a gift to your eyes. The universe will one day fall silent, but tonight it sings. As you breathe in the quiet of this moment, notice how your mind softens when you hold the vastness gently. Questions about the universe's fate dissolve into a sense of calm wonder. The weight of everyday worries begins to feel lighter, not because they disappear, but because you now see them floating within a much larger story. This is the quiet power of cosmic perspective. It does not erase the details of our lives, but it reframes them in a way that brings clarity and peace. You're not small because the universe is large. You're meaningful because you are aware of its largeness, because you can look up and feel something stir within you, something curious and soft, something uniquely human. The universe may expand across unimaginable distances, but only you can experience what it feels like to wonder about it. Throughout history, people have turned to the stars not just for navigation, but for reassurance, not just for science, but for comfort. The night sky has always been a companion, steady, watchful, mysterious, patient. And you are part of that ancient conversation. Your thoughts, your breath, your presence tonight are threads woven into the same cosmic tapestry as the stars themselves. In that way, you embody the infinite now, a moment of consciousness in a universe filled with matter and energy, but so few places where awareness blooms. You are a point of clarity in an ocean of time. You're a brief but brilliant window through which the universe becomes aware of itself. This is not poetry, this is perspective. The atoms that make up your body were forged in stars that lived and died long before Earth existed. You're literally made of starlight cooled into form. And while the universe's far future may be written in possibilities that stretch beyond imagination, the present, this breath, this heartbeat, this thought, is entirely yours. It is easy to think of endings as shadows, as something to dread. But the end of the universe, when viewed across the fullness of cosmic time, becomes less of a shadow and more of a gentle horizon. It reminds us that every story has a shape, and every shape has a beauty. The meaning of a song does not require it to last forever. It matters because it is heard. It matters because it is felt. The same is true of your life. If the universe will one day cool into silence, then the warmth you feel now, your joys, your memories, your loves, becomes even more radiant. If galaxies will one day drift out of sight, then every night sky you witness becomes a treasure. If stars will eventually fade, then watching them shimmer while they're still here becomes a privilege beyond words. As you reflect on everything we've explored tonight, let your mind settle like dust drifting softly onto a windowsill. Let the immensity of the cosmos be a source of comfort rather than distance. Let the thought of endings make the middle glow with new significance. The universe is vast and ancient, but your presence brings it meaning. The fact that you are here, listening, wondering, feeling, turns the story of the cosmos into something personal, something intimate. And so, as our quiet journey reaches its close, allow yourself to rest in the simple truth that you belong to this universe. You are part of its light, its history, its unfolding mystery. The stars above you continue their patient dance, each one a reminder that the cosmos is still alive with beauty. And here, in this small, warm corner of time, you are a witness to its glow, a spark of consciousness cradled within an infinite now. Take a breath. Let the world soften around you. The night is vast, but you are safe within it. The universe is ancient, but you're exactly where you belong. And whatever the future holds, whether it arrives in a whisper or a wave, the present moment remains your own gentle eternity.